Today we're going to look at three different definitions. We're going to look at equations, tables, and graphs. And what we want to do, we want to learn what they are, and we want to learn how, given one of these, to find the other two. So if you are given an equation, also create a graph and a table. If you're given a table, we want to be able to create an equation and also a graph. Now, first let's define these words. An equation shows us how the variables are related. So take, for instance, we have this equation, h equals 12s. We have variable h and we have variable s. This equation shows us how they are related. H is 12 times s. All right, when we look at a table identifies the values that make an equation true. They show us the solutions, possible solutions for an equation. So we would have the value for s, we would plug that in here and get the value for h, and we would write them down here. A graph is a visual image of the values in the table. So once we have this table, or once we plug in values for the equation, we plot them on a graph and it gives us a visual representation. So for our first example, we want to look at an equation here, and this equation comes from a word problem. So it's describing the height of an airplane seconds after, however many seconds after takeoff. So 12 seconds after takeoff. If it's 30 seconds after takeoff, it would be 12 times 30 equals the height of the airplane. And may or may not be true, but that's our example right now. So we have our equation here. How do we want, and we want to create a table and a graph. So our first step is let's just plug in some values here, and we're just going to keep it simple. We're going to plug in 0, 1, 2, and 3. 0 times 12, our height is 0. 1 times 12, our height is 12. 2, 24, and then 36. So very simple. Our table shows us a set of the possible solutions. Our next step is to create a graph. Now, all of these, if you look at these ordered pairs, think of this as x and this as y. And these would be our ordered pairs. You'll notice positive, 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 positive. They are all positive. That means they are in quadrant 1. Now, when we do problems like this and we create a graph, we don't need to draw all 4 quadrants. We only care about the quadrant where our solution set exists. So our first point has 0, 0, and we need to put a scale on here. So we'll do 0, 1, 2, 3, 4, 5. Down here, that works fine. These numbers are a little bit bigger, so I'm going to use 10, 20, 30, 40, 50. Now we plot our first point at 0, 0. Our second point at 1, 12. 2, 24. 3, 36. And then we can draw a straight line connecting them. Now we have a graph that is going to give us a visual representation of the data in our table that was gathered based on the equation. For our next example, we're going to start with a table of values, and we want to create a graph, and also we want to come up with an equation that will give us these values. So we're going to start with our table, and remember, the x, y values, it could be a, b, it could be whatever variables you put in there. But our result is that we're going to have ordered pairs. After we get our ordered pairs, we're going to go over here and plot them. And again, we only need to draw the quadrants and enough space on our graph to cover and to hold our values. So our first plot is at 0, 1, 0, negative 1. Right here. X is 1 and 0, 2 and 1, and 3 and 2. And notice here, I did write my scale, but I didn't write the 1 and the 2. As long as you label your scale enough so that we know how you're counting, everything is okay. And again, then, when we're done, we connect our line here. So this graph gives us a visual representation of the data and the solution set in this table. Now, to create our equation, we want to look at the relationship between x and y. Now, we're always going to start with y equals. So what does y equal in relation to x? So I'll just write an x over here. What do we have to do to x to get to y? 0, we subtracted 1. Okay, so that's what we did in the first step. Let's check the second step. Did we do the same thing? X minus 1 is 0. 2 minus 1 is 0. So x minus 1. And there we have our equation. For our final example, we're given a graph. And from that graph, we want to fill in the values for the table. And then we want to come over here and create the equation to describe this function. Now, again, when we look at the graph, we've only got quadrant 1. And instead of x and y, we have t and d. And right now, I don't care what that stands for. It could be time, it could be distance. It's irrelevant. We know that t is our x value and d is our y value. So we write them over here on our table for x and y. And then we simply fill in the points that were given to us on the grid. So t is 0, y is 2, or d is 2. And then we have 1 and 4, 3 and 6, 2 and 6, and 3 and 8. So to create our tables, simple. We just look at the plots, the plotted points, and we write the ordered pairs on our table. Now, when we want to create our equation, again, we're looking for the relationship between t and d. We want to find d. What do we have to do to t to figure this out? So when we look at our table, our first thought might be, let's add 2, because 0 plus 2 equals 2. So let's try that. We add 2. We test it out now. 1 plus 2, that equals 3. That doesn't work. So we know we have to do something different. So is there anything, what can we add to? So 1, if we do 1 plus 1, so we would do t plus 2. That gives us 4. What's t plus t? That is 2 times t plus 2. Let's see if that works now. 2 times 0 is 0 plus 2 gives us 2. 2 times 1 is 2 plus 2 equals 4. 2 times 2 equals 4 plus 2 is 6. 2 times 3 equals 6 plus 2 equals 8. So then our equation is d equals 2t plus 2. All right, today we're going to look at arithmetic sequences. So first we want to define a few terms that we're going to use. You can see on the board we have the word sequence. A sequence is simply an ordered list of numbers or objects, and we call these numbers or objects terms. Specifically, an arithmetic sequence is when the difference from one term to the next is always the same. It's constant. And when we have a constant difference, it's an arithmetic sequence, and we call the difference from one term to the next the common difference. So let's look at a few examples here. Let's suppose we want to find the common difference when we're given a sequence. So here we have this sequence, 6, 12, 18, 24, and it goes on and on. We're told this is an arithmetic sequence, so we know that the difference from one term to the next is always the same. How do we find that? We do 12 minus 6, 6. So the difference here is 6. The difference here is 6. Our common difference is 6. Once we know the common difference, it makes it very easy to find the missing terms. What goes next in this list? We have 6, 18, or 6, 12, 18, 24. You can all guess the next number is 30. And if we keep going, 36. And on and on and on. We're going to add 6 every time. The final thing we want to do is, looking at our arithmetic sequence, let's identify and create a function so that we can find the value y for the term at position n. So here's the term this is position, n, the number. So this would be 1, 2, 3, 4. Think of these as like slots. So at position 4, what would the value of y be? And again, these are my y values. So we look at that and we decided our common difference is 6. If I take 6 times 1, I'm going to get the value in position 1. If I take value 6 times 2, remember our position, n, is 2. My value is 12. So for the function, for this sequence, it would be y equals 6 times n. And this function here will give you the value for any given position n.